Hello, so in today's video here, we're going to look at the first major topic in the A-level math syllabus, and that's proof. And specifically the subtopic we're going to look at today is proof by deduction. So what do we mean by proof by deduction? So if we want to prove a mathematical result or a mathematical statement, we can use different techniques of proof, and one of those is deduction. So what we mean by deduction is basically using algebraic and mathematical reasoning to prove that a result must be true. And I think when I do a couple of these examples, it'll become more clear what I mean by that. So I've written a few examples here of questions that you may get that will involve you to do proof by deduction. So if we look at this first one here, so prove that the sum of three consecutive integers is divisible by 3. So I mean, if you look at an example like that, you're not going to be able to prove this statement by picking three random consecutive integers and adding them up, and then picking another three random consecutive integers and adding them up. You're going to have to use algebraic and logical reasoning to try and prove that result, rather than just picking random sets of consecutive integers, adding them up and seeing what you get, because you'd be here for the rest of your life and you still wouldn't be able to prove it, because you wouldn't still be able to take all of the integers, because there's infinitely many integers. So you have to prove this using an algebraic argument. And the same with this example number 2. So prove that the sum of the squares, sorry, my handwriting, let me just make that clearer. So prove that the sum of the squares of three consecutive integers is never divisible by 3. So again, we want to prove this for all integers. So if you want to prove something for all integers and you want to prove divisibility, then it's always going to be deduction. So yeah, we're going to have to use algebraic reasoning and algebraic calculations to prove this statement. And the same with this third example. So prove that n cubed plus 3n squared plus 2n is divisible by n, and divisible by 6. And I should make it clear that n is an integer itself. So n is an integer. And remember from the previous video, my first video, we use this notation to say that n belongs to the set of integers. Okay, yeah, so let's go ahead and prove this first statement then. So prove, let's just underline it. So prove that the sum of three consecutive integers is divisible by 3. Okay, so with this one then, how do we do this one? Well, let's just choose any random integer. And we're going to do this algebraically, because we're going to have to do this algebraically. So let's let n be an integer. So n is just any integer. It can be anything. So that means that the next consecutive integer is going to be n plus 1, which is also obviously an integer. And the next consecutive integer after that is going to be n plus 2, which is also an integer. So what we have here is three consecutive integers. And what we're going to do is, sorry, let me go back, is we're going to just sum them. Yep, so we're going to sum those three consecutive integers, and we're going to see what we get. So we're going to do n plus 1 and plus n plus 2. So we can just collect the like terms and simplify this. And we're going to get 3n plus 3. Okay, I'm actually going to factorize this and take the 3 out. So we get 3 times n plus 1 like that. So the question asked us to prove that this sum is divisible by 3. Okay, so if we look at the result that we got, so we calculated the sum and we got a result that looked like this. So 3 times n plus 1. Well, obviously 3 is an integer. N plus 1 is obviously an integer because we specified that n is an integer. So we've got an integer times by 3. So this must be a multiple of 3. So clearly we've got a multiple of 3 here. It's a multiple of 3. So clearly this sum must be divisible by 3 if it's a multiple of 3. So therefore we can say that the sum is divisible by 3, and therefore we prove the result that the sum of any three consecutive integers that you like will always give you a multiple of 3. So rather than picking 1, 2, 3, adding them up and seeing what you get, or picking 100, 101, 102, adding them up and seeing what you get, we're using algebraic reasoning to prove that this is true for all values of n. So it doesn't matter what integer you take, this result will always hold true. So yeah, that's the first example done then. So we've done this. Let's look at this second example. So prove that the sum of the squares of, let's just underline this, so the sum of the squares of 3 consecutive integers never divisible by 3. Okay, so let's have a go at this one then. So yeah, example 2. So this time we want to do the sum, but of the squares of 3 consecutive integers. Okay, so let's pick a random integer and we'll call that n. So let n be an integer. Then obviously the next integer, the next consecutive integer is going to be n plus 1 in the integers, and the next one's going to be n plus 2 in the set of integers. So the question wants us to sum the squares of these 3 consecutive integers. So we're going to square these integers. So we're going to square them. N plus 1 squared, n plus 2 squared, and we want to take their sum, the sum of those squares. So we're going to add them like so. Okay, so now we're just going to have to expand the brackets to simplify everything and see what we get. So we get an n squared plus, expanding that there, so n plus 1 times n plus 1, you should get n squared plus 2n plus 1. And then expanding this n plus 2 all squared, you should get plus n squared plus 4n plus the number 4. Okay, great. So now let's tidy everything up that we've got here. So we've got n squared plus n squared plus n squared. That's 3 lots of n squared. We've then got 2n plus 4n. So that's going to be a plus 6n. And then we've got 1 plus 4, which gives us 5. So we get this result there. So the sum of the squares of any 3 consecutive integers for any n value n is going to be 3n squared plus 6n plus 5. So the question is asking us to prove that this number is never divisible by 3. Sorry, never divisible by 3. Yeah, so that's what we want to do. So if we look at this result that we get here, so we've got 3 times n squared plus 6n. If we actually look at this first part, we can actually factor out a 3 with those first 2 terms. So we get 3 times n squared plus 2n, and then plus 5 at the end there. Again, I'm just going to make my writing a little bit smaller. Okay, great. So now what we get then, so we know that n squared is obviously an integer because n is an integer. 2n is an integer because n is an integer. So we've got an integer here times by the number 3. So this entire number must be a multiple of 3. So a multiple of 3. So we've got a multiple of 3 plus the number 5. So this, so this is a multiple of 3 plus the number 5. But that is never divisible by 3, is it? So you've got a multiple of 3. So any number in your 3 times tables, if you add 5 to it, you're not going to get a number in the 3 times tables because this is not divisible by 3. So not divisible by 3 because 5 is not in the 3 times tables. So you've got a number not in the 3 times tables plus a number in the 3 times tables. This is not going to be divisible by 3. So this entire result is not divisible by 3. So therefore, the sum, which is just equal to this 3 times n squared plus 2n and then plus a 5, is not, so it's not divisible by 3. If we didn't have that plus 5 there, it would be. I mean, if we had like a plus 3 there or any other multiple of 3, then the result would be divisible by 3. But this plus 5 means that this result can't be divisible by 3. And so therefore we proved the result there. Okay, great. So that's example 2 done. And let's look at this last one here. So prove that n cubed plus 3n squared plus 2n is divisible by 6, where n is an integer. Okay, so with this one here, it's probably going to be best to factorize it because we can see that each of these 3 terms share an n in common as a factor. So with this, I'm thinking let's try and factorize it. That's probably going to be the logical thing to do because, I mean, if you look at this n cubed there, I mean, we don't know if that's divisible by 6. It may be, it may not be. If we look at this 3n squared there, is it divisible by 6? We don't know. It's definitely divisible by 3, but we can't tell if it's going to be divisible by 6 because of this n squared there. And this plus 2n, well, we know that's divisible by 2, but is it divisible by 6? Not necessarily. So we've got to do some algebra to kind of see if we can simplify this expression in any way to help us get a conclusion. So let's just write this out here then. So this is exercise 3. So you've got n cubed plus 3n squared plus 2n. So yeah, so as I just said, it's probably a good thing to factorize this because we can't really make any argument based off this there. We don't have enough information just by looking at that. So let's factorize it. So we can definitely take out an n, and we're going to get an n squared plus 3n plus 2, like so. If we look at this this expression there, can we actually factorize that? Well, yes, we can. So let's try and do that then. So we get n times, well, it's going to be an n there and an n there. So two numbers that times together to make 2, but add together to make 3. Well, that's just going to be 1 and 2, isn't it? So plus 1 there, plus 2 there. Okay, so does this help us out in any way? Well, what we notice is that we have 3 consecutive integers. So we've got an integer n, because we know from the question that n is an integer. And then we've got the next integer after that, n plus 1. And then we've got the next integer after that, n plus 2. So this is the product. So the product of 3 consecutive integers. Okay, so how can we argue that this number must always be a multiple of 6? Well, okay, so we've got 3 numbers which are consecutive, 3 whole numbers which are in a row. So we should know for a fact that one of those numbers must be a multiple of 3. So if you pick any 3 consecutive numbers, so let's say 2, 3, 4, well, this 3 is obviously in the 3 times table, so we've got one multiple of 3 there. Let's pick another example. So let's say 27, sorry, I'll do it in black ink, 27, 28, 29. So that's another pair of 3, well, another set of 3 consecutive integers. So what we know from this list is that this number there is a multiple of 3. And what you can do is you can pick any 3 consecutive integers that you like. You're gonna always get one multiple of 3 in that list. So what we can say from here for a fact is that one of those numbers must be a multiple of 3. So therefore, either n plus 1, n plus 2 must be a multiple of 3. So yeah, so one of these numbers exactly has to be a multiple of 3. So we're doing a multiple of 3 times by 2 other integers. So therefore we know for a fact that this result is a multiple of 3. So therefore we know for a fact that n cubed plus 3n squared plus 2n is divisible by 3. So we know that it's divisible. We know that it's divisible by 3. But obviously that's not what the question asked us to look at. The question asked us, is it divisible by 6? Okay, so we know it's divisible by 3, so that's going to help us out, one would think. So how can we now show that this result is divisible by 6? So if you think about it again, if we look at our list of numbers up here, so 2, 3, 4, and then 27, 28, 29, well, this is even, isn't it? So that's divisible by 2. And that's an even number there, isn't it? That's divisible by 2. Let's go to list number 2. So you've got 27, 28, 29. Well, we know that 28 is an even number, so that's divisible by 2. So what you can do is you can pick any 3 consecutive whole numbers. One of those numbers at least is going to be divisible by 2. So either 1 or 2 numbers in that list of 3 will be a multiple of 2. So let's make a note of this here. So let me just tidy this up there. So we also know that either 1 or 2 of these consecutive integers, so of these consecutive integers must be even. So because we know that 1 or 2 of them must be even, Well, it means that we're basically doing, well, we've got two cases. So let's consider the case that we have one even number in our list. So let's consider case number one. So case one, one of the integers is even. So what you're doing then is you're multiplying a multiple of 2, so multiple of 2, by a multiple of 3, because we know that one of them must be a multiple of 3, and then times by some other integer. So that's going to give you a multiple of 6, because an even number times by a multiple of 3 is always going to be a multiple of 6, because a multiple of 2 times multiple of 3 is a multiple of 6. So in this case here, we're definitely going to get a multiple of 6. So if we have one even number in this list, so if that number's even, if the middle number's even, it's got to be the middle number. If that middle number's even, then n and n plus 2 are odd. And we've just explained that in this case, we're going to get a multiple of 6. But let's look at the case where the first and the last number are even. So case 2. So what are we going to get? So we're going to have 2 of the integers are even. And in that case, what we're doing, well, we're doing an even times an even, which is definitely going to be an even and definitely a multiple of 2. So we've got a multiple of 2 times by a multiple of 2, another one. And we know that, well, one of those integers must be a multiple of 3. And even if it is one of these even numbers, well, it's still a multiple of 3. So what we're really doing is a multiple of 2 times multiple of 2 times multiple of 3. So it's going to be clear that this again must be a multiple of 6, because any multiple of 2 times by any multiple of 3, or any number that is divisible by the product of 2 and 3, is a multiple of 6. So this is a multiple of 6 as well. So basically, this argument is telling us that the product of 3 consecutive integers must be a multiple of 6, because one of these integers is going to be a multiple of 3, and at least one of those integers is a multiple of 2, and a multiple of 2 multiplied by a multiple of 3 is a multiple of 6. So therefore, what we can conclude from here, let me just move the writing up to that, and that number 3 up to there like that. So what we can say from here is that definitely it must be true that therefore n cubed plus 3, so 3n squared plus 2n must be, let me write that again, must be divisible by 6. And that is our result done. Yeah, so an argument like this would be fine, where you can kind of justify that one of those numbers has to be a multiple of 3, and then one of those numbers at the very least is going to be a multiple of 2, and any multiple of 2, any number that is a multiple of 2 and a multiple of 3 is definitely going to be a multiple of 6 as well. So yeah, so that's that exercise done. So proof by deduction will always be examples like this. So normally proofs where you've got to prove that a result is divisible by something. That's normally the typical standard questions for proof by deduction in the A-level exams. So yeah, that's the end of today's video.